I'm going to do the second part of the arrow shot into the air question. It's asking how far sideways does it travel? What's the horizontal distance? I know a few things from the previous problem, or the previous part of the problem. So I'm going to fill in what I know from what I had before. The arrow is going to go up at an angle at 52 meters per second, and using cosine I found that sideways, that meant it was traveling at 43.12. I found that in the first part of the problem. I also know that vertically it's going upwards at 29.078 meters per second. I'm going to say that it starts out at, I'm going to say it starts out at 0 position. I need to find out its final position. Its initial velocity sideways is 43.12, and it's going to continue to do that all the way, so its final velocity is 43.12. I don't know its time. Well, I know its beginning time is 0, but I don't know its final time. So I don't have enough information to use in this equation on this side. I don't know the time yet. So I'm going to have to pop over to the other side, where I found that the height that it reached was 43.13929. That was the answer to the previous problem. The initial velocity upwards was 29.078. Final velocity upwards, if I go all the way to the top, is 0. But what if it comes all the way back down again? The velocity would be in the negative direction, but since I already plugged in my final value, the y final is at some positive height, I'm going to say that its speed when it gets there is 0. It's at the top of its arc. Start the timer at 0. I'm going to find the amount of time it takes to get up to the top. Okay, so going through my list of, gravity is 9.8. Going through my list of equations, probably the top one here is the simplest to get time. So I'm going to take that one. Final velocity in the y is initial velocity in the y plus gravity times time. And solve for time. Subtract off initial velocity in the y and divide by gravity. Oh, plug in my numbers. 0 minus 29.078 meters per second divided by a negative 9.8 meters per second squared is equal to my time. Divided by negative 9.8. So the amount of time it takes to get to the top, 2.9671, blah, good enough. Okay, I'm going to come over to the other side with that time. I have to be careful though, because that's the amount of time it takes to get to the top. This question is asking, how far sideways does it go? Which means it has to go up to the top and come back down again. And with projectile motion, if it starts at a height and ends at the same height, it reaches the top at the halfway point. So really this time is just only half the time. So the time of the entire flight is equal to 2 times my 2.9671 seconds. So that's what I'm going to put into my table up here. So 5.9343, and then the equation I'm going to use to get distance is delta x is equal to VIX, using the initial velocity of 43 and the time of 5.9343 seconds. Get a distance $255.946 meters. And we're done.